r theta. All right, let's do, I know this is kind of weird, but it kind of makes more sense to do it in this order. Let's do 54 together first, okay? So this is a little bit of a fill-in-the-blank situation here. It says that the second differences are all 2. So I'm going to work backwards from there. If the differences here are 2, what's the missing number? Good, -6, because -6 is 2 away from -8, okay? And then you can use similar reasoning to figure out this missing number is going to be 2, because the fact that the second differences are all 2 apart means that all of these numbers have to be 2 apart, okay? So then 14 minus 8 is 6, so that's how we got that. Then 6 minus 6 would be 0. 0 minus 4 is -4. That's where that came from. Then -4 minus 2 is -6. Not a backwards one, just a regular one. Then -6 minus 0 is -6. And -6 plus 2 is -4. Okay? So that's a way that you can find those missing differences, is just by working backwards. Alexandria? Yeah, I just did. Did you hear it come on? Oh, can you hear? It's a little bit, yeah, that's fine. All right, so 51 is a little bit nutso, all right? What 51 is going to do is it asks us to take a step backwards, and it says instead of starting with a table, let's start with a function, make the table ourselves, and then show using that table of values that the third differences are in fact the same, okay? So the first thing that I have to do in making my table is I think that I need, oh yeah, don't mind if I do, maybe 6 numbers that we're going to plug into the function, okay? 2, what else? 8. Nope, I want them to be in order. 4. I want them to be in order. 1. So let's keep it simple. Let's go 0 through 5, okay? So what I have to do is I have to take each one of those numbers and plug them into that function and see what I get as an answer, okay? McKenna's response to that is appropriate and correct. She's like, what are you talking about? That seems like an incredible amount of work. Okay, let's use technology to help us. So Sydney, you have your book open. Keep that open for me, would you? Oh, never mind. So I have that function typed into Desmos already from my first period class. So what was the first number that we wanted? We wanted to plug in 0. Okay, so if I plug in 0, then I get -6. So I'm going to write that right here. Then if I plug in 1, I get -10. And then if I plug in 2, I get -14. Then if I plug in 3, I get -12. If I plug in 4, I get 2. And then if I plug in 5, I get 34. Okay? So there is our table of values that this time we created all by ourselves based on the equation that they gave us. What we're going to do now is show that in this case the third differences are all the same. Yeah. Okay. Right. So I just worked backwards. So this here says every one of these numbers is off by 2. So if I start at -8 and I add 2 to that, then I'll get -6. And I can kind of check that that works, because then if I take -6 and add 2 to that, then I get -4, so it fits. And then the same thing here. If I add 2 to 0, then I get 2. Okay? So then to here, I'm going to take 14, and this time they're all different, but they're listed for me right here, so I'm okay. So 14 minus 8 is 6. And then 6 minus 6 is 0. It is. So the difference between here from 14 to 6 is negative 8. If I start at 14 and I go down 8, I end up at 6. Okay, so you got it? All right. Okay, so let's go back here and let's do exactly what Callista was asking about with our table of values. How far is it from negative 6 to negative 10? Negative 4. Negative 10 to negative 14 is another negative 4. Negative 14 to negative 12 is positive 2. Negative 12 to 2 is plus 14. And 2 to 34 is positive 32. Okay, those are our first differences. Those are not all the same because it's not linear. Let's look at the second differences. What's negative 4 to negative 4? 0. How about negative 4 to 2? Plus 6. And then 2 to 14, plus 12. And 14 to 32 is plus 18. Those are also not all the same, which is good because this is a cubic, not a quadratic, okay? Right, so now if we look at the third differences, those are all 6, and so that fits because that is a cubic function, and so we would expect that not the first, not the second, but the third differences would all be the same. Okay? What's the matter? All right. The next part is crazy, okay? But what we're going to do now is we're going to do this with just the general formula for a cubic equation, okay? So we're going to start out by doing the same thing. I'm going to take 0, 1, 2, 3, 4, 5 and plug those in for the x's, okay? So if I plug in 0 for the x's, what do I get? 51 still. I get D, because this would be 0, this would be 0, this would be 0, but this does not have an x, so it's going to stay there, okay? Well, that's not actually there. It's a comma from the problem statement. Okay, what do I get if I plug 1 in for all of those x's? No? A plus B plus C plus D. Okay? Well, because 1 to the third is just 1. Okay? However, 2 to the third is not. What's 2 to the third? 8. So that means when I plug in 2, I'm going to get 8a, because 2 cubed is 8. When I plug in 2 here, then I'm going to get 4b. When I plug in 2 here, I get 2c, and then plus d. Okay? What is 3 cubed? 27. So that's going to be 27a. What's 3 squared? Good. So 9b plus 3c plus d. And let's do one more. We'll skip number 5 because Anna is like gonna, if we don't stop doing this. I know, right? I know. That's why we need to stop. There's a lot at stake here. What's 4 cubed? 64. So 64a plus, 16b plus, good, plus d. Okay, and then like I said, we'll skip 5. All right, now let's start figuring out these differences. What is a plus b plus c plus d minus d? Good, a plus b plus c. What is 8a plus 4b plus 2c plus d minus a plus b plus c plus d? 7a. Awesome, okay. How about if you subtract these, what do you get? All right, somebody said it, 19a Good. Okay, and then the d's cancel. What do you get if you subtract these? 37a. Good. All right, so those are the first differences. Are they the same? No, but we wouldn't expect them to be because it's not linear, it's cubic. So let's keep going. What do you get when you subtract those? Yeah. Go ahead. Okay. What do I get when I subtract 6a plus 2b? When I subtract these, I get 12a and 2b. And when I subtract these, I get 18a plus 2b. Alexandria? Yep. I'm doing 4c minus 3c. And that gives me the 1c. Okay? All right, second difference is also not the same. Good, if I subtract these though, the 2b's cancel. 12a minus 6a is 6a. These, the 2b's also cancel, and 18a minus 12a is 6a. So that means that the third differences were the same. So we just started out with the most general cubic equation that we could, and then we showed that the third differences were the same. Okay? That's not something that I'm going to require you to be able to like do on your own. It's just something that maybe 2 or 3 of you in class might find mildly interesting. Okay? All right. Any other questions then? Yeah. Calculus. Yeah. Yeah. Right. Yeah. Okay. We good? Okay, hang on to your assignment.